Welcome, ladies and gentlemen. So what I like to do is show you how to write the vector when given the magnitude and angle. So previously, when we were trying to write an angle, we were either looking for using component form or as a linear combination. Well, given the information, it's going to be pretty difficult to write it as a component form or linear combination when we're just given an angle as well as the magnitude. So we don't have a formula right now to kind of understand that. So what I want to do is just kind of understand a little bit as far as what information we're given, and then try to make sense of that so we can find a new way to write a vector as in our component form that we can put to linear combination. And to do that, what I'm going to do is look at our lovely unit circle. All right, so remember when we're looking at the unit circle, one of the important things about the unit circle was, it had a radius of 1. And I'm just going to look at 30 degrees here. Now, remember when we were talking about 30 degrees, we found some coordinate points. And on the unit circle, we found these coordinate points to be square root of 3 over 2, comma 1/2. Now, if you remember, where did these points come from? How did we figure out those points? Well, what we did was we created a right triangle. And what this did is this actually created a special right triangle. And the relationship, because our hypotenuse was 1, we could use special right triangles to find our side lengths. But then once we got a little bit more into trigonometry, what we really understood, though, was we could also use trigonometry rather than the special right triangles to figure this out. And what we understood was square root of 3 over 2 is really equal to the cosine of 30 degrees. Now, we use special right triangles because if you type in cosine of 30 degrees, you're going to get a decimal unless your calculator gives you it as the radical, right? So if we just typed in cosine of 30 degrees, we wouldn't really make sense that it's a square root of 3 over 2. That's why we started with special right triangles. And 1/2 really represented the sine of 30 degrees. Because remember, if here's my sine of 30 degrees, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So those values, and when you type in sine of 30 degrees, you get 0.5, which is 1/2. So this value was equal to sine of 30 degrees. This value was equal to square root of 3 over 2. So it doesn't really matter what the angle was. What we kind of figured out was the first point of our coordinate on the unit circle is always the cosine of whatever angle we're dealing with. And the second point is always the sine of whatever angle we're dealing with. So it didn't matter if it was 30 degrees, 40 degrees, 50 degrees. Either way, we always kind of said the x value was cosine of theta, and the y value was your sine of theta, whatever theta was, whatever the angle ended up being. But that's very, very important because remember, when we're looking at vectors, vectors are kind of like plotting a point from 0, 0, right? Except it's a directed line segment. Now, in the unit circle, we know that the magnitude is 1. So if we were going to create a vector here, we know the magnitude is 1. But what if I had a different magnitude? For instance, 3, 1/4, 2, and 6. Well, then all we need to do is multiply that by that scalar. So another way that we can write a vector based on theta is think about cosine of theta and sine of theta as our component 1 and our component 2. Because those do give us those points around there. Those are your points based on the angle that you're given. So a way that we can write a vector, another way, is we can take whatever magnitude we're given and then multiply it by the vector. And instead of using v1, v2, because we don't know v1, 2, we just given the angle, we can say that the first component is equivalent to the cosine of theta, and the second component is equal to sine of theta. Because think about it, same way. If you were going to point this, you would say that's v1 and that's v2. So cosine of theta is equivalent to v1. Sine of theta is equivalent to v2. Now, a lot of times we actually just simplify this. We distribute that in, and we write it like this. Okay? And that's basically all we're going to be doing for these problems, is taking our magnitude and our angle and plugging them in. Now, we have to remember, though, the points on the unit circle. So, I don't know why I erased that, but if you remember on this unit circle, I had that one correct. Here's 30 degrees. That point is square root of 3 over 2, comma 1/2. Right? So we have our vector, and I'm just going to use v equals magnitude of v times the cosine of theta, comma magnitude v times the sine of theta. Okay, so we know the magnitude is going to be 3. Cosine of theta, remember we said cosine was right there, so that represents the x-coordinate, which is square root of 3 over 2. comma, magnitude, which is 3, times the sign, which is the y-coordinate, which is 1/2. Now, we just go ahead and simplify. And I have 3 square root of 3 over 2, comma, 3/2. Now, that vector is this exact same vector, but rather than having a magnitude of 1, this vector has a magnitude of 3. Okay? So for the next example here, we have 1/4, and a magnitude of theta is negative 120. So we need to figure out what are the x and the y coordinates basically of that point on the unit circle, right? Well, we have a little issue because negative 120 is not in the first quadrant. Negative 120, well, if here, remember, going this way is positive, this way is negative. So from here to here, it would be negative 90. So negative 120 somewhere around here. It's an extra 30 degrees over the 90, right? So that's going to be our theta, which is negative 120. The way that I like to do this, because I have the first quadrant memorized, is I find the reference angle. So the reference angle is the angle from the terminal side back to the x-axis. And that theta prime, if this is negative 120, that means this is going to be 60 degrees. Now, the reference angle is always positive. So basically what I need to do is figure out what is my coordinate point at 60 degrees. Well, that point is comma 1/2, 1/2 comma square root of 3 over 2. So that point, however, this point is now in the third quadrant, right? Because negative 120 is the angle down in the third quadrant. So it's the exact same coordinates, except there's just negative. So now when I find my vector v, basically what I'm going to do is I'm going to take 1/4 times the cosine of negative 120. Actually, I'll just write that out. Comma 1/4 times the sine of 120. Okay, so I have 1/4 times cosine, which is the x-coordinate, which is negative 1/2, comma 1/4 times the sine, which is negative square root of 3 over 2. And then I just simplify. Remember, when multiplying fractions, multiply numerator times numerator, denominator times denominator. And I get a final vector of negative 1 over 8, comma, negative square root of 3 over 8. And again, you can kind of always check your work, too. Notice how this vector, both my components are negative. That means I'm going to the left and I'm going down, which is going to give me the same vector in the same direction of negative 120 degrees. However, it's now going to have a magnitude of 1/4, whereas this one is in the first quadrant, just like that angle in 30 degrees would be. All right, so to do 315, well, we know all the way around a circle is 360, so 315 is somewhere right around here. So we say theta equals, let's put theta down here. Theta equals 315 degrees. So my reference angle is how far do I need to go to get to my x-axis? Well, if from there to there is 315, that means I need to go an extra 45 degrees. So I use my reference angle to figure out what is the point in the first quadrant at 45 degrees. Simplify that right there. And at 45 degrees, that point is square root of 2 over 2, comma, square root of 2 over 2. However, since my point for 315 degrees is in the fourth quadrant, I know the y-coordinate is going to be negative. So the point that I'm going to use for the problem is going to be the exact same point of what's in the first quadrant based on my reference angle, but it's going to be the y-coordinate is going to be negative. So I'm just going to kind of simplify this here. So I have 6 times the cosine of 315, which is square root of 2 over 2, comma, 6 times the sine of 315 degrees, which is negative square root of 2 over 2. Okay? Then 6 divided by 2 is 3. And that becomes 6 times negative 1, which would be negative 6. Negative 6 divided by 2 is a negative 3 square root of 2. Okay? In the last example, we have an issue here. Well, first of all, we know 108. If we're going to look at this, well, actually, you know what? Yeah, whatever. Oh, let's double check. Is that in the second? Is that in the fourth quadrant? Yes, that is. So we know from here to here is 90. So 108 is right here. The problem is we don't have a value of 108 on the unit circle. So what are we going to do? Calculator. And I avoided using the calculator for the rest of these problems. I used the unit circle because if you just type in the calculator, again, the calculator is going to give you a decimal approximation for square root of 3 over 2. Or decimal approximation for the square root of 2 over 2. And we don't really want a decimal approximation. We want the exact values. Or at least on my test, that's going to be the answer that I'm going to be looking for. But in this case, 108, we're going to have to go with approximations. So my vector v is going to equal the magnitude 2 times the cosine of 108 degrees, comma, 2 times the sine of 108 degrees. Because I can't really get around it. I can't find the exact values of sine and cosine of 108 degrees. They're not coordinate points I know on the unit circle. So therefore, all I'm simply going to do is just plug this in my calculator, 2 times cosine of 108. Just make sure, since we're dealing with degrees, that you're in the correct mode, that you're in degree mode on your calculator. And when I do that, I am going to approximate to the third decimal point. So I have negative 0.618. And then I'll do 2 times sine of 108, and I get 1.9002. Okay, so there you go, ladies and gentlemen. That is how you write the vector when given the magnitude as well as direction. Thanks.